Okay, so today we will learn about steam formation, how steam is generated in step-by-step procedure. So first let us consider first figure, that is written point A. Okay, consider 1 kilogram of water at 0 degrees Celsius and we have put a weight W on the piston. So as you can see, throughout the process we are not changing the weight, okay, and neither we are changing the cross sectional area of this cylinder. So pressure will remain constant throughout the process. Okay. So as we have said, at point A we have selected a water at 0 degrees Celsius. So now we will provide heat to that cylinder. So we can observe a slight increase in volume of liquid till 100 degrees Celsius. We all know that boiling point of water is 100 degrees Celsius. Okay, so it is considered as saturation temperature of water. Okay, so saturation temperature means the temperature beyond which it cannot further raise the temperature. Okay, further addition of heat will start converting will start the change in phase. Okay, so at point B the water will be now at 100 degrees Celsius, that is at saturation point. Okay, so now further addition of heat will start to convert the wet particles of water into dry particles of steam. Okay, so in figure number 3 we can see some portion of water is converted into steam. So here particles shown is dry particles and below that these are wet particles. Now if we further continue adding heat, so these remaining water particles will also be converted into dry particles. So at point C in figure number 4, what we see here is all dry particles. Okay, this state of steam is called dry saturated steam. In this state there is no wet particle present in system and volume at that time is Vg. Now if we further continue to add heat, then these dry particles, means this dry steam, will be converted into superheated steam. So from point C to point D we can see a rise in temperature of steam. Okay, because there is no wet particle present at point C to take further heat, so it will increase the temperature of the system. Okay, so at point D there will be a higher temperature. Okay, so one thing to observe is from saturated liquid state to dry saturated steam, the temperature of the system remains constant, that is saturation temperature. Here we have in figure number 2 we have water at 100 degrees Celsius. In figure number 3 we are having a two-phase mixture of water and steam at 100 degrees Celsius, and here point C we are having a dry saturated steam at 100 degrees Celsius. So in figure 2, 3 and 4 we are having same temperature. Okay, so let's understand this through TH diagram. Okay, so TH diagram looks like this. Okay, so let put it by point. Okay, so at point A we are having a 0 degrees water at 0 degrees Celsius. Okay, so on this graph temperature 0 degrees Celsius is at point A, that is at origin of this graph. Now at point B we are having water at 100 degrees Celsius. So temperature will rise as well as enthalpy. Now what is enthalpy? Enthalpy means total energy available in the system. Okay, as we have said here, at point A we are having 0 degrees Celsius water and point B we are having 100 degrees Celsius water, means we are adding heat. Heat is a form of energy. So we are adding energy in system at point A to achieve the position at point B. So enthalpy will also increase up to point B. Now from point B, at point B we are having a saturated liquid at 100 degrees Celsius. Now from point B we are further continue heating, so we are experiencing a change in phase. Now water particle is now starts to convert into dry particles or steam particles. Okay. So from point B to point C we can observe the phase change phenomena. Okay. Now at point C, as we can see here, all the particles are dry. So this state is called dry saturated steam. Now point B to point C we are not experiencing any change of temperature. So this process will be at constant temperature. Now from at point C if we continue adding heat, so now there is no wet particle to take up the heat, so there will be increase in temperature of the system. Okay, so we can, and as well as we are continuing adding the heat, so we are continuing adding the energy in it, so energy will also increase. Okay, at point D we can have a superheated steam, that is temperature is T superheated. Now enthalpy of point up till point B is known as sensible heat, means we are adding heat to increase the temperature of water from 0 degrees Celsius to 100 degrees Celsius. That energy, that heat is known as sensible heat. Amount of heat required to change the phase at same temperature is known as latent heat of evaporation sometimes. And amount of heat required to increase the temperature of system beyond saturation temperature is known as enthalpy of superheat. Okay, so here we can identify different states of a steam. At point B we can say there is a steam which is completely wet, so we can say it is saturated liquid. At point C we have a steam which is completely dry, means there is no moisture present at point C, means all the particles here are dry particles, and in between point B and C we are having a wet steam. Okay, so to identify the quality of wet steam, there is a term known as dryness fraction, indicated by X. Now dryness fraction means the amount of dry particles present in this mixture of dry and wet particles, means it is indicative of how much amount of dry particles are present in the system, and opposite to that is wetness fraction, which indicates amount of wet particles present in the system. Okay, so dryness fraction will indicate quality of steam. If steam is more wet, so its quality will be lower. If steam is more dry, then quality of steam will be higher, because we know that if we use a wet steam in power generation, means steam turbine, then it will create some problem of corrosion in turbine blades. So it is beneficial to use dry steam in power generation. Okay, so we consider quality of steam is higher if steam is more dry. So in this TH diagram, if steam is near point C, means within this region, then it is considered as high quality steam. If steam is near point B, means within this region, then steam is more wet, so it is considered as low quality steam. Okay. Now how to find the dryness fraction of a steam? Suppose for example consider a system which is having 10 balls with 4 ball A and remaining 6 ball B. So to find out how much portion of ball A contains within the system, we can simply we are having 4 balls of A out of total 10 balls. So we can say 0.4 proportion is of ball A. Similarly, to find out dryness fraction, consider a system which is having some portion of wet particle and some portion of dry particles. Okay. Consider this system, that is system number 3, which is having some amount of wet particles and some amount of dry particles. So as I said, dryness fraction is amount of dry particles present in given system divided by total mass of the system. Okay. So amount of dry particles present in the system is, suppose mass of dry particle is ms and mass of wet particle is mw, mass of water and mass of steam. So amount of dry particles divided by total mass of the system is, so this whole system contains steam as well as wet particles, dry particles as well as wet particles. So total mass will be ms plus mw. So that is dryness fraction of a steam. Okay, now from this equation of dryness fraction, we can say value of x can vary between 0 and 1. Okay. It cannot go below 0 or it cannot go beyond 1. Means if we consider value of x is equal to 1, that is ms is equal to 1, it will indicate that this system is having only dry particles. Okay. There will be no wet particles. So in that case mw will be 0, that is ms by ms will be equal to 1. Means that case is of this point number C, where we are having only dry particles, no wet particles. Okay. So at point C in TH plot, also at point C, value of x will be equal to 1, because we are having all dry particles, no wet particles, not wet particle is present in the system. And if we consider value of x is equal to 0, if we consider value of x is equal to 0 in this equation, then ms will be equal to 0, ms will be equal to 0. Okay. Means this system is having only wet particles, no dry particles. Okay. So it will indicate this point number B, where it is having all the wet particles and no dry particles. In TH plot it is at point B. Over here value of x will be equal to 0. Okay. So keep in mind this thing, value of x varies only between 0 to 1. Value of x is 0 at point B, where we are having saturated liquid, and x is equal to 1 at point C, where we are having dry saturated steam. And in between this, value of x will vary from 0 over here to 1. If value of x is equal to 0.5 means it is at middle point. Value of x is 0.7 means it is near point C. Okay. Now x is 0.7, okay, and it can vary only between 0 to 1. So, 0.7 is nearer to 1 means it is nearer to point C. Okay. So, we can say it is more dry. So, quality of steam will be higher. Similarly, if X you can say 0.1, okay, so it is near to 0. Okay. So, it will be near point B. So, here steam will be more wet. Okay. So, quality of steam will be lower. Okay, so now let us talk about enthalpy of steam. As I said, enthalpy means total energy available with the steam. So, let us consider first law of thermodynamics, that is Q is equal to delta U plus P dV, that is work U plus W, that is the first law of thermodynamics for a process. So, let us simplify it. As I said, all the process that we have seen in steam formation is at constant pressure, because we were not changing the load W as well as the area. So, pressure was constant. Okay. So, if you further simplify it, we can write so U plus PV is enthalpy. Okay. So, we can say heat supplied is equal to change in specific enthalpy. Heat supplied is equal to change of specific enthalpy. Okay. Keep in mind, I am using the word specific enthalpy. Specific means per unit mass. In steam formation, we have considered a mass of 1 kg only. Okay. So, that is why I am using the word specific enthalpy. So, another term is enthalpy of liquid. Enthalpy of liquid. So, in TH plot, if you recreate here TH plot, saturation temperature point A, B, C and D. So, liquid was present in the system, okay, saturated liquid was up to point B. Okay. So, that is enthalpy of liquid. Enthalpy of fluid from point A to point to reach from point A to point B is HF. Okay. That is enthalpy of fluid. Next, enthalpy of dry saturated steam. Dry saturated steam. Okay. So, in TH plot, dry saturated steam is present at point C. Okay. In TH plot, dry saturated steam is present at point C. Okay. So, that is enthalpy of dry saturated steam. It is denoted by Hg. Enthalpy of liquid is denoted by HF. Okay. So, amount of energy available to reach the system to point C, that is dry saturated state, that is known as Hg. Okay. So, we can divide this energy into two parts. First portion is HF, means energy required to reach up to point B, HF, and another portion is enthalpy of evaporation, that is HFG. Okay. Amount of heat required to change the phase completely from point B to point C is known as enthalpy of evaporation denoted by HFG. So we can write Hg is equal to Hf plus HFG. Enthalpy of dry saturated steam is equal to enthalpy of fluid plus enthalpy of evaporation. Okay, next is enthalpy of wet steam. So we are knowing that wet steam, first let me write enthalpy of wet steam. Okay. So in TH plot, wet steam is present between point B and point C. Okay, within this region we are having wet steam. Suppose if I want to find enthalpy of a wet steam at this point, point 1, suppose I want to find the enthalpy of wet steam at point 1, means this much amount H1. So I can further divide into two sections. First one is HF. We are knowing this, that enthalpy up to point B is HF. And what about this? Okay, so we are knowing that enthalpy up to point C, means point B to C, is HFG, and this is some amount of HFG. Okay, so we can write it as X HFG. So H1 is equal to HF plus X HFG. Now, is this equation correct? Let's verify it. Substitute first, substitute value of X is equal to 0 in this equation. So what we get? H1 is equal to HF plus 0, that is HF. Means if we are taking X is equal to 0, this point 1 will be over here. Okay, and enthalpy up to point B is HF. Second, consider X is equal to 1 in that equation. So H1 will be equal to HF plus HFG. Okay, means point 1 will be over here. If I consider X is equal to 1, means completely dry system. Okay, X is equal to 0 means completely wet system, saturated liquid state, and X is equal to 1 means dry saturated state. Okay, X is equal to 1, so H1 is equal to HF plus HFG, which is the enthalpy of dry saturated steam. This is the enthalpy of saturated liquid. Okay, so this equation is mathematically correct. H1 is equal to HF plus XHFG. Okay, so if I want to find an enthalpy between point B to point C, okay, I can use this equation HF plus XHFG. By varying the value of X, I can vary the point between point B and point C. Next is enthalpy of superheated steam. Enthalpy of superheated steam. Okay, now we are talking about superheated steam. Okay, so in TH plot, superheated steam is present beyond point C. Okay, the amount of heat required to raise the temperature of water beyond saturation temperature is superheat. Okay, so superheated steam is present beyond point C. Suppose I want to find enthalpy of point D, that is superheated. This is enthalpy up to point D. This is H super, enthalpy of superheated steam. So now I can divide it into two parts or three parts. First, consider about two parts. Okay, so enthalpy up to point C is enthalpy of dry steam Hg plus enthalpy from point C to point D. Means we are knowing that enthalpy, we have seen right now, enthalpy, change in enthalpy is equal to amount of heat required. So HD minus HC, enthalpy at point D HD minus HC will be equal to amount of heat required, and amount of heat required is Cp T super minus T saturated. Okay. We are knowing this equation that amount of heat required to raise the temperature is Cp dt. Okay. Here written Cps means specific heat of superheated steam and change in temperature. Okay, temperature is changing from T saturation to T super. Okay, so we are taking the difference T super minus T saturation. Okay, so this enthalpy is Cps T super minus T saturated. Okay, so we can write H super is equal to Hg plus Cps T super minus T saturated. Okay. We can further divide this Hg into Hf plus Hfg, okay, T super minus T saturated. So based on data given in the example, you can select any of these equation. Okay, next is degree of superheat. Now degree of superheat is the difference between the temperature of superheated steam and dry saturated steam at a given pressure. Okay, so degree of superheat is simply the temperature difference, T super minus T saturated. Next is amount of superheat. Amount of superheat is basically amount of heat required to raise the temperature of steam to superheated temperature, or the amount of heat added during the superheating of steam is known as heat of superheat or amount of superheat. It is equal to Cps T super minus T saturated.